don't upgrade your lights to LEDs because they're unreliable and very wasteful, because you have to throw away this whole thing every few months or whatever when they stop working. Got this out of the bin. Factory was retrofitted. I got rid of the good T5 high output Highbays and put in these unreliable things, and so there was a skip bin half full of these about a year later because they failed. If you plug it in, it just flickers. It's quite interesting if you turn it off. So it's still plugged in but the switch is off. It still goes. And if I unplug it now, it stops. And if I plug it back in with the switch still off, it starts flashing again. I don't know what that means. Anyway, Pierlite, I don't know what that says. So it's a 240 volt model, which is interesting because I thought the world was moving to 220 and 230 depending on where you are. IP65. So it's got some dip switches in here supposedly to change, because it's got some setting there. It says lumens output, and then on here it tells you the watts. So the lowest is 100 watts and the default is 200 watts, and you can choose that, and that relates to a driver current from either 640 milliamps up to 1.2 amps. Doesn't say anywhere what the voltage is. So presumably this is a lot of collections of series and parallel LEDs. It's very hard to see the traces, but it looks like there's a track there, it says positive next to it, which comes out down here, and then that spreads off in both directions around this, and then the negative side, I'm not exactly sure where that goes. It definitely connects to that ring. Oh, okay, I can see, we need to take this cover off, but yeah, the negative side is down there and the positive side is down here, so it must be going the whole way around. Anyway, let's get some of this covers off and we'll have a look at the LEDs. Perhaps we'll try and power them up by some other power supply. We'll look at what the power supply is in this thing and try and work out, is the LEDs wrecked or is it the power supply that's wrecked? Why is it flashing like that? The other reason why you don't want to use these types of lights is because they create a very bright point source of light. So when you're trying to work in the factory, your eyes are being dazzled by these really bright things just out of the corner of your vision. Whereas you never had that problem with the fluorescent tube type lights, because those have a very large surface area that the light comes from. So it's not such a bright point source of light. It's much more comfortable to be around than these horrible things. Also, these are pretty flickery depending on how quality the driver is, which can upset some people. Flickery light. That was the problem with all the ones they put into the office area. Like violent flickering, which was not very good. So just stick with the fluorescent tubes, the discharge lights, and the sodium lights. The power savings is negligible, and they last a lot longer than these cheap, nasty LEDs. I guess it's a money-making thing, isn't it? Because whoever decides to put in the LEDs will meet their cost-saving targets on all those false claims, and then it will be in the maintenance budget to keep replacing these in years to come, but that's someone else's budget, so it doesn't matter. Okay, there's a lot of screws, and they're fairly tight. And I guess there's a seal around here to check against moisture ingress. Okay. Yes, there is a rubbery thing there. Okay. Oh, it's some kind of push-fit connection. Looks like it. Guessing there's also heatsink paste around the back of this board. Well, there should be, to hold it against this fairly rough aluminium casting. I don't think it's aluminium, is it? It's some other stuff. We need to get some that type of thing. 4 of these. That's interesting. Maybe that's to do with grounding, that it brings it from that over to there. And it looks like these smaller screws just hold the cover on the back of this driver module thing. This was all wet when I got it. It rained and the bin that these were in got quite a lot of water in it. But because this is IP rated, it probably is still safe, isn't it? It was pretty dirty. Bits of rust on the washers here. Yeah, evidence of it being wet. Oh, okay, look at that. The driver thing is a separate... It's not Pierlite or whatever that name was on there. P-I-E-R-L-I-T-E. Pierlite. Okay, this thing though is Ad-Ayo, and it says, oh, that's got a different range. It's now 220 to 240 volts. Different. The output is 130 to 155 volts, 1.2 amps. And it must be quite a lot in series then. That's going to be a bit more difficult to power it from external power supplies, and I don't know what kind of power supply I've got in that range. I might have to join some stuff in series. I'll probably make it. I've got a dual 20 volt power supply and a dual 36 volt power supply. I think we can get there with that. But this should light up with a bit less, shouldn't it? Maybe. It depends how the LEDs are feeling. Might not be feeling that generous. Let's have a look at the driver first. Yeah, might be able to get a little bit of a glow out of it. Oh, it's potted. Look at that. Oh, I guess we won't be able to see very much then, will we? That's a bit disappointing. I wonder if it's possible to pull that out. There's another bung thing. Oh, that's where the dip switches are. Okay, well that's how you do that. So set to all off. Set to all off, which is that the brightest setting. There's some kind of ring there, but the potting stuff has gone on the outside of the ring. I suppose this was to be expected, wasn't it? It is the type that breaks away, so we could make a huge mess and try and get access to this. Yeah, let's do that. I wonder if I can get this whole module to pop out as one thing, and then we can start picking at it. Perhaps we'll try to undo that connector thing off the LEDs, and then try those out first before we tear into that power supply thing. I guess this is some kind of compression seal thing. It looks like it. Ah, this looks like it's been very hot because those are peeling away. That's just cracking away, that insulation-y stuff. So that's a type of connector that once you push the wire in, it won't come out because there's little teeth that will grab it. Just bend those out of the way. Okay, soldered connection into that spring terminal. That's a little bit dodgy, isn't it? Maybe the only problem is that these aren't connecting properly anymore. That's possible, isn't it? Well, they're gone all burnt. Sort of suggests bad connections, but maybe this thing just gets so hot when it's running normally that they would just burn up. Anyway, we'll have to sort out some power supplies, and we can try turning on these LEDs, and then also we'll see if we can get this thing out and make a massive mess with this gross ass potting stuff because it goes everywhere. Wreck my screwdriver. I have a bigger screwdriver. I need something bigger. going to destroy it in the process because it bends the board so much. Guessing it's a round circuit board, unless there's nothing in this area. No, there's stuff in that area. So it must be a round circuit board that fills up most of this thing. Oh, it's so close to coming out. Just wonder, probably this eye on the back will have a nut on it, and that's probably squeezed itself around, like the potting stuff squeezed all around it, and so it's going to hold itself in. There is some kind of other stuff around that dip switch, so they must put a little hat over the dip switch so that the potting stuff doesn't go in and flow into it. Makes sense, wouldn't it? How many that fails on and it just gets covered over anyway. But these will hardly ever get the settings adjusted, so it probably doesn't matter. The other thing is this one around the input power cable. That's probably all glued in. Yeah. Cut that out because yeah, this will have to suck itself in when the board gets pulled out, because it will be all glued up around the back of it. Yeah, probably by pushing that we can get it to come out. The other option would be to drill another hole in this and then push from that side. Probably could push on the dip switch as well, but I really want to destroy the dip switch. Yeah, just do that. Alright, I think first, before we get too messy with all this business, we'll set up a power supply, or some power supplies, and we'll try turning on the LED panel, and then depending on what happens with that, we'll start pulling apart the power supply. But I need to get some bits set up to power these LEDs, so I'll just do that. Alright, we'll start off with something simple. We've got here this one, lambda, 20 volts per channel, in series. I used to have two of these, but I lent one to somebody and then they didn't get around to doing the job they wanted, and then they passed away and disappeared. But it's a little bit dodgy because it's got a barrier strip on the back there for connecting the AC input, which is, you gotta watch what's behind it because you don't want to accidentally liven up something. Anyway, so we'll see what happens when you get up to 40 volts on this. Current limit, we'll set it down fairly low. Okay. Oh, okay. There's a row of LEDs there that are glowing just a little bit. A very small amount, but yeah, it's not really enough to do much, so we need more volts. So that means we've got to turn on a very noisy power supply that's over there, and I can't move it because it's got all sorts of junk piled on it. And then we'll have more volts. Yeah, we've got more power supply over there. Oh, can we get this? I just want to check what the output voltage is, just to make sure we got that set up right. And it's set to series mode, 72 volts, and that's a 1.5 amp limit. I suppose we should turn that down a bit because this is a bit dodgy. We'll set it to 0.2, 200 milliamps. And so we'll plug that in and see if this comes on, and if it doesn't, then we'll join that one in series as well. Oh, look at that. Again, it's just that middle ring. It is a bit strange, isn't it? And it's below the threshold though, because it's saying on the screen 4 milliamps. So that means we've got to join this one in series as well. So we'll put that positive onto the negative here. These clips are too big to fit in the binding posts and the banana connections. And get another lead and join that onto there. We'll turn that on, and then we'll increase this one. It's up to 40 milliamps. But it's not flickering, is it? That's interesting. Do you think they've designed it so that the lights, some chains are longer than others? I don't understand why they wouldn't all want to come on at the same time. That flicker's just noise in the pots. Anyway, it seems like we need more volts to make it go higher. I'll just think about what I can do about that. Alright, so we can add nearly 24 volts more with this thing. "22-ish" by the look of it. So let's do that. It's getting a bit dodgy. Now it's drawing 140 milliamps. So probably the conclusion from this is that the LEDs are fine. It's getting a bit too dodgy for me to produce more volts than that. What can I use? Got, oh I know. Why don't we use a insulation resistance tester? That'll be a good thing to do, wouldn't it? It's not going to produce enough amps though. The current won't be enough. But let's try it anyway, just to see if we can get them all to glow. And it's probably limited to 1 milliamp, so it's not going to show up very much. The other option is a high pot tester, which would do like up to 10 milliamps. Let's just see what this does. If we set it on the 500 volt range or 250 volt range, will be fine. Heavy clips. I don't think it's enough current. That's a shame. It's probably only like microamps, isn't it? Oh well. Flash tester then? High pot tester? Yeah. No, we'll just say the LEDs look like they work, so that's that. Which means the problem must be the power supply, but unfortunately it's hard to get into the power supply to see what its problem is. But we'll have a go, or at least start the process. Whether I finish it or not, we'll see. Depends how long it takes to get all that goo out of it. Let's have a look at the back side of this board to see, did they put any heatsink paste on there? Probably proper Phillips, aren't they? Not JIS. Nope. Oh, I don't know what they are then. That's pretty interesting. That's a number 1 JIS supposedly, and so is that, but this one does not fit, and this one does. Interesting. This one fits perfectly. That's very weird. Both of these are number 1 JIS. That's very loose. That one is only very slightly loose. It's about the same. Okay, so there's different angles or different point lengths. Alright, does this come out? Okay, they've printed a grid of dots on it, so there is some kind of token gesture thermal paste on there, but you can see, well, you might be able to see, a very weird interference pattern. It's come from the LED strips up there. And you can see the shadow caused by the clamps that are holding the camera stuff. When you look at this pattern, it seems like it was barely pressed down, but it's different in different areas. There's some areas where it seems quite well squashed around the mounting holes, obviously, but only around one side of them, which is probably shows how much the aluminium deforms when you drill or punch holes in it. So it seems to be pressure around there and there, but not, it's not even now. And there was a key, that thing there. So it's better than no thermal paste, but it doesn't really appear to me that it has good thermal conductivity. Do we need to try and reverse engineer? Do we need to try and trace out the circuit of the LEDs to see what is in series and parallel? Problem is, because it's 150 volts or whatever it said, that's a lot of series connections. 130 to 155, so the series amount of LEDs will be somewhere within that range. Problem is, with this stuff I can't easily tell which one's a track and which is the gap between the track. Anyway, it seems to snake through these. Great, that's the LED thing. Yeah, if you really want to trace it out, look in your local skip bin for one of these things. I'm sure there'll be plenty in there. Alright, we'll see if we can get this thing out. I wonder if we try and get that off. The thing is, it's probably threaded multiple times. Threaded through the housing and then with a nut on the back of it. So it won't be able to just unscrew from the back. I wonder if this has PFC. It looks like there's multiple magnetics there. So it possibly does. Well, it is 200 watts, isn't it? So that is within the like power rating that you'd probably mandate to have a PFC input. Which also means it probably would run on 110 volts as well, or other voltages if it had PFC. It's found that stuff does seem to run on wider input voltages than what they claim on the rating plate, usually. Especially if it's got input PFC, although it probably won't be too happy with it because you'll be stressing things a bit. Higher boost on the input converter, higher peak currents. Good. I'll see if I can get this thing out, and if I can get it out, then we'll carry on and take a look at it. Alright, here's the deal. The board is screwed down in there. You can see the back side of some studs in two places, there and there. You see it's one of those things but mounted around the other way. So that means in order to get it out, we have to burrow down through there, find the screw and undo it, and burrow down there, find the screw and undo it. Otherwise it ain't coming out. So what I was thinking of doing was getting a nibbler or a hacksaw and sawing off like a channel down the side of this so I could get to the bottom of the board and start... What is going on? Get to the bottom of the board and like then pry it up from the bottom of it, because the stud poking through components here, which means we're going to destroy it in the process of trying to get it out. But now that I know there's some screws in there, that explains why it's not just popping out. Makes sense there's no screws in there because I got to ground the suppression stuff. Why is that flickering? It seems like there's a bad connection up here on the camera, and just shaking the bench is enough to upset it. There you go, look at that, there's a screw in there. Oh, it'll be so much easier to undo when you get out when you undo the screws. All that reefing on it for nothing. Okay, and then the other one's down there, I think. No, other side, it's down there. Alright. There's the other screw. It'll just pop out easily now, won't it? No wonder some sides felt more loose than the others, because we're bending it from over here and over here where there aren't the screws. It'll just slop out easily, won't it? Oh, look at that. So much easier. Just falls out now. Great. Oh yeah, look at that. There you can see the bolt thing that holds that eye on. Tip switches, the little thing. And we can peel this surround off, which which presumably was supposed to hold the potting compound in there. And we've got a long road ahead. Oh, there's another sheet in there. Okay. I'll probably get back to you once this has progressed a bit more, because yeah, this is tedious and it's going to take a long time. Destroyed that resistor, great. Wonder how the cable's connected in. There must be something there. Maybe it goes through the board, through a hole, and then it's connected on the other side. Stuff's gonna be going everywhere for finding it for weeks now, aren't we? It's gonna be just all over the place. So it's just flying away. Oh look, the dip switch is an add-on board. Yeah, I was supposed to take a photo of this thing in its original form for the thumbnail. Oh well. Oh, look at that. I found the problem. There is some on the some soot. There's some soot on there, and we can see an explosion has happened there. Ah, okay. So if we clean that, it'll probably start working again. Perhaps we should plug it back in and try it. Because what will be happening, depending on where that is in the circuit, it looks like it's in the output path. So there's the output wire, various filters and things all the way around here over to here. And so it looks like, and that will be whatever it was, 150 volts something. So it's probably just tracking over. That's why it was flickering like that, because the voltage will rise up, breaks down across this carbonized track that it's created, and then it shuts off on overcurrent, or over something. Yeah, over, well, it's a current limited power supply, isn't it? Well, it clamps the voltage down because of the resistance of the arcing or tracking, and then the tracking stops conducting. The voltage rises up again, and you get flickering. Let's just uncover the rest of this bottom piece so we can investigate the circuit. So hopefully I haven't destroyed anything too much. And we can, I don't think anything got destroyed. Just be careful of the windings of the inductors and things. So that did get a bit of a poking. And that resistor there got scraped, but that's probably still okay. So let's turn this thing on. Well, we've got to clean that first. It does look like it's arced over the main conductive path. We just look at this circuit for a little bit. It's got various input filtering there. There's a fuse there. Mains coming in. There's a rectifier there. Then off the rectifier there'll be an inductor, which will be that one there. Oh, this isn't an isolated converter, is it? Not sure. It doesn't have high isolation. Just looking at the way these tracks go around. Okay, so that wasn't a grounded post, it's only that one there that's got ground on it for the suppression. Guess it's one of those buck converter things. Thought it'd have an active front end. It probably does. So those FETs on there, or diodes, on that one. And that one has one device on it. There's something else on there with those pins. Not sure what that is, unless that's the inductor pins. It doesn't seem to have a PFC booster on it, it's just... yeah, it's one of those ones that has a very low input capacitance. So there's almost no input bulk capacitor, and that way the power factor isn't so bad as when you have big DC bus cap on a rectifier connected onto the mains. So it'll be probably less than a microfarad. Let's just clean this little bit of tracking. Maybe we should leave it and watch it arc. Too late, cleaned it. Guess that was going over to there. Anyway, let's join that back up to the LED thing, and then we'll just plug it in and see what happens. If I put that on the top, just thinking, how can I lay this so it's not going to short it out? I guess that will be fine. That down or something so that it's sitting on something that's not going to short it out. I just have to recover these little one-way clip things because I bent the little terminals out as part of the thinging, getting it out. Now the brown wire was the positive. Alright, we're going to just plug it in and see what it does. Because why not? And we'll see if it works now. What have we got to lose? Maybe we should turn it down a bit. No, we want full force. Just want to make sure that the heat sinks are not touching the frame. Good. Alright, let's find the cord. Plug it in without that moving. Moved. I don't think it's too dodgy, is it? Okay, let's see if this turns on. No, it went bang. Okay, did you see anything? I wasn't looking at it because it's dodgy, but should we try it again? Maybe not. It just hisses. Alright, I guess that wasn't the only fault then. Well, actually, I've introduced more faults by poking it around. I think that's what's going on. I probably shouldn't touch it now because there'll be capacitors charged up. But I'm guessing something happened in the process of pulling it out and bending the board so much that we've broken something else. That's a shame. I thought we'd found the problem. Well, we probably did find the problem. It's just we wrecked it in the process of finding the problem. Hopefully you heard that crack noise that it made. Oh, I wonder, just staring at that closely, that bit that had that arcing on it, that's probably a dry joint. So it's not actually arcing across, it's just a bad connection. That's what that looks like. I wonder if we should solder that back. Or is it too late now? Probably already destroyed it. But yeah, if you look very carefully at that, it looks like, yes, it's arcing when I put the screwdriver there. So that, I think it's a dry joint, and because it has high voltage across it, it sparks, and maybe that's what happened because I cleaned it. So maybe let's try soldering that back together, and then we'll try it again. We'll just have to touch it very carefully. Well, I need to measure it properly and find out where is there some voltage. There'll be voltage across there. Some sort of input cap. No, there's nothing there. And on the output, I think it got discharged by shorting that out. Yeah, look at that, there's 70 volts between the track there and that node. Wow, okay. Alright, I'll tidy that up and then I'm gonna have to run away at the moment and come back in a moment. But we'll see if we can get it going by soldering that dry joint back. Okay, we'll carry on. I was distracted because there was new Lucario avatar model testing to do, so I went and did that.
Yeah, but like, can you like tell me something about the hobby?
Interested in the what?
Like,
But now I got this camera out, and I'm going to try and take a close-up look at that burnt solder connection just for fun, to see what's going on there. The only problem is I got this really tough time trying to locate it because it's zoomed so far in. But if it wasn't zoomed far in, then we wouldn't be able to see it as well, would we? Here it is. So it's fully burnt. I don't think we're going to get much better picture than that because I can't hold it still enough. But yeah, that's been crackling away for a while. So that's probably the only actual problem this has got, or the only problem it did have until I wrecked it by trying to rip it out of the board, not trying to rip it out of the housing, not realizing that it's screwed in. Because I thought it was just placed in there and then some glue or whatever put on it, that potting stuff. So we'll try to solder that back. We'll get the soldering iron on, and hopefully it's discharged enough now. And we'll give it another test just to see, does that bring it to life, and whether it does or doesn't, we'll peel off a bit more of that stuff and have a look at it and see if we can look at the circuit a bit better. But because that's been burning and sizzling away, it's not going to be that easy to solder because it turned into gross as stuff. But let's just see, let's try it anyway. The soldering iron's a bit crustified. Let's give that a good cooking. We can just blob over it. The leg is all, like down the side of the leg, it's all like charred, so it doesn't readily accept solder anymore, but if we blob over it, it should make enough of a connection for us to do a test. And then we'll just try it out. That's what we come here for, isn't it? To try this thing out. We'll see if we can fix it. So, let's see. Sit that there so it's not going to touch anything. And I'll sit that there so it's not going to touch anything. And then I'll carefully plug this in and we'll see what happens. Nothing. Yeah, I guess it got cooked. Really? Nothing? Alright, does nothing. That's weird. It's made noise before. Maybe that was it parting company for the final time. I thought we were going to fix it. Guess not. Nothing there. Nothing there. Oh, do you think the input fuse blew when that popping happened before? That's possible, isn't it? The input fuse will be across there. Let's just check that. No, input fuse did not blow. Okay. Weird. Guess it's just dead then. There's definitely nothing there. 30 volts. 30 volts. There's about 25 volts between those. I wonder, did that really make a good connection? Don't know what those components are in there because it's all sealed in by that stuff. Some more pretty dodgy soldering. Ah, look, there is another bad joint, which could have been caused by us. It's still connected, but it's definitely cracked. We can inspect that. The problem is, how do we find it? It's here at the end of this. See that? It's got a crack around it. Dry joint. Classic thing, isn't it? Single-sided board, pretty bad lead-free soldering. Well, lead-free soldering sort of includes the word pretty bad, doesn't it? That's just how it is. But yeah, bad crusty soldering, single-sided board, so there's no solder going through the holes, and you end up with very thin bits of solder holding large parts, and any movement and it cracks. Because that was probably caused by trying to get this thing out of the casing. But I think it's only on one side. It metered out as still being connected, so it's probably not what's causing the problem right now. Oh no, I lost it again. It's down here somewhere. I wanted to see around the back of it. See the back side. Well, it's got that grey crud on it. Anyway, that's the power supply. It doesn't work, even when we resoldered that dodgy joint. That's a shame. But anyway, we found what is most likely the cause of this thing failing, and that is bad power supply, not bad LEDs. That's good. So if you do have these, it'd probably be a good idea to turn down the brightness a bit by adjusting these switches. Ooh, that one's very stiff. It might be because we push... yeah, it's because I was trying to get it out by pushing on that. So yeah, it'd probably be a good idea to turn them down to the next highest brightness, because otherwise you'll find that the LEDs will just overheat and get wrecked after a while, because they're not... the connection between the LED panel and the heatsink casing thing is not very good, and it probably varies between units. So you might find if you fit out your factory with a whole bunch of those things that a whole bunch of them fail because like 10% or whatever. I don't know what the amount will be. Going by how many of them were in the bin where I found this, it could be quite a high percentage of them will fail within the first year or so, and probably a bunch of those will be because of bad thermal connection, and the rest of them will probably be because of what we saw on this, which is something's gone bad in the solder. It's another thing you got to think about if you're potting your products, because the thermal expansions, these things run hot, as we know from all LED things that just smoke away all day, and then at night they get turned off, they cool down. And if this potting stuff has a different thermal expansion than the components in metalwork and housings and things, then it will put great stress on the parts as it tries to shrink and grow a bit each day, and then that can wiggle things around and cause those type of bad joints, cracked solder joints. So, okay, I wrecked it now, I think. Just ripped a winding off of an inductor. So, if you're going to be potting your electronics like this, I'd highly recommend that you use through-hole plated boards, because that will give a lot more rigidity and like a lot of more hard-wearing solder connections, which will be very beneficial for long-term reliability, because the solder goes all the way through the hole and you get a good meniscus on each side if you do it properly, and that is a lot harder to crack than what we have here, where it's a single-sided board, copper only on one side, not through the holes. There's just a very thin piece of solder between the component leg and the copper on the board, so it doesn't take very much to crack that. So there's an option there for another capacitor, which they haven't done. I guess that's a cost down exercise, isn't it? Doesn't matter if it's flickery, just get rid of some of the cost. That's on the output, is it? Because that's the output wires there, and it comes along there, and then there's a final filter, another capacitor, and the output wires. And then that looks like a ferrite for the input. Oh yeah, those two wires there, there's a red and a black wire, they'll be coming in from that dip switch board. That's expensive, isn't it? Making a whole nother board and having to attach it. But there's not much choice. See, these parts on the bottom will be through wave soldered, so they'll get glued down and then be soldered at the same time as all the other through-hole parts in wave solder. Oh, look at that, there's a connector in there. So that dip switch wire can be unplugged. That makes sense. So it'll be manufactured as two parts and then it's plugged together with no further soldering needed. Good idea. Oh, it actually, the board that the dip switch is on has got a whole bunch of resistors there. So when you change that dip switches setting, it will be choosing a resistor value. It's probably in the current feedback path of, or the sensing of the current feedback for the switch mode thing. Just wondering if the reason it didn't work is because the damage I put on that resistor bit. I don't think so, that's just minor. There's only really the end cap that's scraped, so that wouldn't have affected its value. as if it scraped down the side of where the carbon trace thing is on the resistor, and it could have broken it and made it go open circuit. Yeah, I recorded another video where I'd done something very similar to this, picking out this crud, but I haven't uploaded it yet because I wasn't very happy. Maybe if you tell me you want to see it, then I can finish it off. What it is a teardown of one of these power supplies, Slump 150 watt laptop and USB-C charger. Let me know if you want that finished and uploaded. It was recorded a long time ago, but I think then I wasn't very happy with the circuit analysis part and I was going to redo it and then didn't get around to it. There's a cut trace. Must be an option for something. Unless I destroyed it. There. A cut link, I mean, not a trace. A cut link. It must be choosing some option for something. And it looks like this does have a PFC booster and as well as an actual buck converter thing, because that will be the high voltage. Is that a 500 volt cap, 450 volt cap there? Oh, that's what was... Okay, we found what the leg that has come off, or burnt off. That's the leg of that capacitor, so that was pretty important. No wonder it was sparking then when I was pushing on that leg, because yeah, that would have had voltage on it, 450 volt. Well, that probably would run it around 400 and something, so that's interesting. And there's some links under the capacitor and an insulator in between the capacitor and those links. Good idea. Got to treat the bodies of electrolytics as live, because yeah, the can will be live and that sleeve doesn't really count as an insulator. So we've got to be careful putting topside tracks underneath electrolytic capacitors, because you might just find that it gets joined to it. Okay, so this does have a proper PFC booster. That's good. Well, is it 200 watt rated, so it's in the region where it's probably mandated. Like the bigger laptop power supplies, they always have them. Once it's over sort of 150 watts. Okay, there's not much point in peeling more of this out, is there? Alright, we'll have a look at the board, and then we've got the power coming in on this cable here. Comes through just a single turn through some ferrite. Gas discharge arrestor thing. That's the ground from the green wire there, and that screws onto the chassis through that little lug thing. Then we got some presumably Y caps. Oh yeah, are they Y caps? Maybe they're VDRs. Yeah, it might be VDRs, and then through that gas discharge thing. So that's for arresting spikes. Then there's the little tiny fuse there, that little brown thing. Probably 1 or 2 amps. 4 amps. 4 amp fuse. Then there's a wire cap across the lines. Then there's a film cap. So there's X position caps. Discharge resistors. They're good. Then got common mode choke there. It's quite a neat winding arrangement like that. Then there's another cap, noise suppression. It's another one of those caps, or VDR if that's what it is. I don't know, what is that thing? 140511KH, and then WLR in front of that. I don't know, I have to look that up. It's probably a VDR, because it wouldn't make sense putting a cap and then another cap in parallel. It's probably a VDR to clamp voltage spikes. Then we've got a full bridge rectifier there, and then after that, that little brown one in there will be the that's the first bit of the input smoothing. Then there's the common mode choke, or just a choke, and then there's another cap there, DC smoothing. 684, 680 nan, 680 nanofarads. Probably the same value as that one in there. Maybe. Can't see it. Then it goes into the boost converter, that's probably the diode for it. So that seems to come straight off there, diode. Then that goes onto a leg, which I don't know where that goes. Is that the boost inductor? Yeah, it's probably that to that as the inductor. And then the other side of the inductor, which is probably those two there, will be the feedback winding. Probably. I think so. Yeah, that's a cap. So that will be the inductor feedback. Yes, you see there's another option for a larger one where it would take those two pins, and that's in parallel with those. So yeah, that's the feedback from the inductor. Inductor pins are there, or there and there. Something like that, I'm not sure exactly. Then there's the FET, and then there's the diode. So it's not on the heatsink, because that's just a hole. This must be the small version, which I guess we already know that because there's that option there for the other cap. So this is definitely the small version. So I think there'll be a bigger cap option there, bigger inductor. So I think this might just have a leaded diode sitting in that gap in there, not one that's on the heatsink. So that's between those two pins there. So it looks like there's another pad which would be more in line with this heatsink, so you could use a TO220 style diode. And then there's pretty much the output with another inductor there in series, which will be, must be another diode, another FET. These two here will be a buck converter, and then there's the inductor and the output, something like that. And that's why there's two control chips. One will be for the PFC and the other one will be the buck converter, which will have current limiting. Means there must be a current sensing resistor somewhere. And that will be, that's some sort of current sensing resistor. You can see there's tracks coming off of it going into the control circuit. Voltage sensing there. Another dodgy looking solder joint, but that's a cap. Yeah, that's broken, but that's probably from us ripping the stuff off. Oh, look at that. The connector where those resistors go can go between a combo choke and then two pins called dim plus and dim minus. So there must be another option of this light, or this driver, where the dimming control is an external thing. That's exciting. I wonder if there's a voltage reference that then drives that. So that's on there. Okay, that is an isolated thing with that. So what powers that? Ah, look. That there, which is the buck converter inductor, has got multiple windings coming off of it. And that there, those two windings there act as a power supply. You can see the rectifier diode there, and then that will be the smoothing cap. So that powers itself up as its own isolated thing so that it can be brought outside of the light fixture and allow a remote dimming option. That's neat. So maybe that there is something like a 555 timer, and it creates a PWM signal across the optocoupler to control the dimming. That would be my very uninformed guess. Can't read what's on those chips. I can't tell if I've rubbed off the writing or whether it's just filled up with flux and stuff. There's definitely writing on these other ones, but again, it's really hard to see. Let's get the thing in. Knock everything on the floor in the process. Okay, let's see. This guy. I have to hold this upright, otherwise I can't move it properly. Is it possible to see any markings on that? It looks like it's been burned off, doesn't it? Something's happened. Anyway, let's look at the next one, which is here. I can't hold it still enough. Does it say MT7660? And on the next row, M906B or 11 or something, I'm not really sure. And then the final one, which would be the PFC controller. ST Micro. Whatever that is. Again, it's very hard to see. Anyway, yeah. not really that concerned about what those thingies are. It's just going to be a generic PFC controller. But yeah, that's cunning. A separate little circuit there for the dimming control, so that can be isolated from the mains power. It probably means that they use a different version of this cable here that's got a couple of other like low voltage separately insulated cores in it, and that will just pop into the cable loom and come out, or it will be another one that comes out alongside this one. And then it looks like you just join some resistors between it, and the value of the resistors determines the dimmingness. The dimmicity, and what was it to start with? Was it all off as the highest? I think that's what it was. Yeah, all off is the highest, and then you apply resistance across it to bring it down. Yeah, shame we can't see what that one is to see what kind of dimmingness it does. So that means the output has to be operating, it has to be switching in order to power up that dimming circuit. Does that mean then you can't bring the brightness down too low because there won't be enough switching going on in the inductor to generate enough voltage to control the dimming circuit? It's like it would be self-limiting, wouldn't it? That if you dim it too low, the power supply goes low, and then that relief increases the brightness back again, and it will balance at some point at a minimum maintainable level. Great! Cheap and cheerful LED lighting. Be careful with it. As in, maybe don't waste your money.